Hello everyone, welcome back to Interview Buddies. In today's video, we are going to talk about embeddings and how you can generate them. So a quick intro about the embeddings are a way of for computers to understand the relationship between things like words, images, sounds, videos. Imagine a high dimensional space um, uh, in which there are like many axes and each representing a different feature of data. For words, this might include things like words definitions, part of a speech, or how common the word is. And then compressing data into a dimension like this high dimensional space can be overwhelming for machines to process. So embeddings take this complex data and compress into a lower dimensional space with just hundreds of dimensions, like fewer dimensions. And then the similar things are encoded closely together. So in this lower dimensional space, the key is that similar things are placed close together. So words with similar meanings or images with similar content will be encoded as the nearby points. So to explain this, let's look at this small drawing. Think about a movie recommendation system in which you want to recommend movies to your audience. So embedding helps by placing similar things close together, and it helps allowing machines to identify relationships between data points. Right, so on my screen we have this x and y axis, and you have this movie called m1, and let's say the data point is 2 comma 3, and there's another movie called as m2, which is like 3 comma 4, and there's another movie called as my, and let's call it minus 1 comma minus comma 2. So in this scenario, these coordinates are embeddings, and the recommendation system will work in such a way that it will recommend movie m2 because it is more closer in terms of embeddings than my. So it will recommend this movie rather than this movie my. So now let's get into the coding part and see how you can generate embeddings using the Python code. On my screen, you see there are a few imported statements, and we have this BERT tokenizer and BERT model. And this tokenizer object is like we are using a pre-trained model here, and then using that we are going to tokenize and generate the embeddings. I have this data, the sample data, and I'm going to generate embeddings only for the description here. This function I'm not using it, get connection, but let's focus on this function, generate embeddings. So here for every description in the data, I'm saying that use this tokenizer object, pass the description, which is your text basically, and I have this return tensors equal to pt, which means it should return PyTorch tensors. If you are using TensorFlow, you might want to use TF. And then the next line, I have model inference. This is a pre-trained model, BERT, and this will tokenize the inputs. And the syntax here, it unpacks the input dictionary and passes the keys and values as keywords arguments to the model. Output, the model processes the input and produces the output, typically including hidden states and other information. So in the next line, we are unpacking that basically. So outputs dot last hidden state, right? So output dot last hidden state, this means that this retrieves the last hidden state from the model's output. The hidden state is a tensor containing the model's learned representation from each token from the input text. Dot mean dimension equal to 1, this computes sorry, I have to highlight that. Yeah, this thing. So this computes the mean of the hidden states along the dimension 1 to get a single vector basically. Detach, this detaches the tensor from computational graph, preventing further computations. And then we have the numpy function here. This is to convert PyTorch tensor to a numpy array. flattens the array to a 1D array, and then converts it to a list. So that's how it's generating the embeddings. Once we run this, you will see how the embeddings looks like on the screen. So that's all in this program. So let's run this. I have two files here, so I'm going to run python gen.py, and it will take a minute. So it just printed the embedding size because I have printed the length of the embedding. So you can see the size is 768, which is fixed and which is what the BERT model returns. For OpenAI, if you are using OpenAI, it returns around 1500 something. I forgot the exact number. That size of embeddings, but this is the fixed size for BERT. So if you want to see how the embeddings looks like, so we'll save it, run it again, and yep, here you see these are like a 768 size vector, and as you can see, there are like a lot of numbers, decimal, some negative, some positive. So these are what the embeddings looks like. So now what? You have the embeddings and how you're going to process them. So next step would be you can save these embeddings somewhere in your database, and then you can, if you have a table, save and data similar to this, you can then search this data, and based on the embeddings values and the vectors, it should return the records which are similar to your search term. So that's all for today. Hope you like it. Don't forget to hit subscribe button. Thank you very much.